Electroplating is a process in which metal atoms are transported onto the surface of another metal using electricity. As a result of this process, the metal's surface is plated in a thin layer of the imported atoms. Electroplating is commonly used for decorative purposes and for preventing corrosion. For example, chromium is a metal which has high corrosion resistance and its appearance is aesthetically pleasing. So, chrome plating is used for decorative purposes, providing corrosion resistance and increasing surface hardness. Besides chromium, zinc is also used for providing corrosion resistance. The process of zinc electroplating is generally called galvanization. Zinc is plated onto steel or iron to prevent rusting. The zinc layer sacrifices itself and rusts over time, so the plated metal is protected, and this process is called sacrifice plating. Electroplating is carried out with a special device called an electrolytic cell. An electrolytic cell consists of a DC battery, electrodes, and an electrolytic solution. The electrode where atoms give electrons is called the anode. The electrode where atoms gain electrons is called the cathode. This means that oxidation reactions are carried out at the anode, whereas reduction reactions are carried out at the cathode. In electroplating, the anode should be positively charged and the cathode negatively charged. The metal to be used for plating must be connected to the anode, whereas the metal to be plated must be connected to the cathode. Also, the electrolytic solution must be a solution of a salt of the metal used for the anode. For example, if we want to plate a piece of iron with copper, copper must be connected to the anode and iron must be connected to the cathode. Also, the electrolytic solution must be a solution such as copper sulfate or copper chloride. Let's say we choose copper sulfate. There are positively and negatively charged ions called cations and anions in the electrolytic solution, and they are able to move freely. When the current is turned on, positively charged cations, copper ions in our example, move to the cathode, and negatively charged anions, sulfate ions, move to the anode. The copper ions have migrated to the cathode, gain electrons, and become neutral copper atoms. Metal atoms typically become solid when in their neutral form. Therefore, copper atoms which gain electrons become solid and build up on the cathode. On the anode, copper atoms lose electrons because of the current. Therefore, these atoms move to the cathode and become solid. This process continues during the presence of the current, so copper atoms create a thin layer on the cathode. As a result of this, the anode's mass decreases and the cathode is plated by copper.
First, we need to fix our sample in electroplating jig. The jig is placed in a gold plating container. That's what we have in container. We're gonna hold the sample upside down in the jig. Make sure the exposed metal area in our sample can contact with the electrodes on the jig. Fix the holder inside the jig. Then place the metal plate. Place the plastic cover plate on the corresponding holes. Then fix the bolt. Please note that the bolts should not be too tight, or the wafer will be damaged. Here is fixed sample. Then we dip our sample into water. There will be a lot of bubble on the surface. These bubbles reduce the quality of the plating, so we use a dropper to remove air bubbles from the surface. Make sure the bubble is fully removed. Gold electroplating consists of electroplating bus and current controller. First we need to turn on the electroplating bus. Switch on the main power. Then switch on the heater and pump. The temperature of the bus was set at 65 degrees Celsius. Wait half an hour to let the temperature reach to the target. Half an hour later, open the lid. Take out the sample to be electroplated. Ensure that the surface to be plated, cathode, needs to be orientated towards the anode. Fix the jig with bolt. Then close the lid. The red wire connects the anode, and the black wire connects the cathode. Connect the black wire with our jig. Insert plug into jig. Turn on the power of current controller. Here we can control the mode. CC means control current, CV means control voltage. We choose CC mode. Use the arrow keys to set the current value. Here is the method to determine the current value. After setting the current value, press the Start button to start electroplating. Then turn on the stirring. This process can improve the process of transfer of substances. After a predetermined time, press the Stop button to stop electroplating. Then turn off the stirring. Disconnect the wire. Open the lid. Loosen the bolts. Take out the sample. Dip into the eye water. Close the lid. Turn off the current controller. Switch off the heater and pump. Switch off the main power. Cleaning round the machine. Swipe any water and keep the clean condition. Take out the jig to take out sample. Loosen the bolts. Take out the plastic plate. The sample will be fixed on the plastic plate, so please be very careful to handle it. Carefully remove it from plastic plate. Remove the metal plate and holder. Reason the wafer under the eye water. Take out wafer and clean it by air gun. Put the wafer back into the wafer carrier. Dry the jig and put it back into container. Close the lid and keep it properly.